Hi guys, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. So today we're going to look at a concept in under limits. And in our first discussion on the concept of a limit, we had said that a limit basically is a value of a function as it approaches a particular interval, or rather a particular value of a particular interval. And we're going to give this specific illustration for the concept of a limit, as I had said, as L, but in various discussions we are just going to give an interval for this limit, or in terms of an expression form. And we had said that we can be able to give the definition for L in terms of of course an equation which can be given as the limit, rather just leave it in this form. We can say that the limit of x as it tends to a of a function fx is going to be given as L. And we had defined L and said that it's basically it's a limit of a function fx as it approaches a particular value a. If for every value of a particular number which was epsilon greater than 0, there exists another number sigma which is greater also than 0. And we had given of course a specific condition that this is going to apply if and only if this particular range of values that we have said for x minus a is greater than, of course, 0, and therefore we're going to have another function sigma which is greater than 0, implying that this specific function then therefore is a range of values of the difference over that specific limit, which is going to be smaller than this specific number, which is of course epsilon. As we said, this is going to be more elaborate, of course, in our various applications, but in a statement form, you can be able to algebraically represent the concept of a limit using that individual or other illustration that I've given on the board. So therefore, we are going to consider a case of a limit of a number that is given in form of a quotient as I've given. So in this case, this is going to represent a range of functions which can be able to be represented as a over b. So therefore, this is going to apply one of the rules that we had mentioned in our previous discussion on the quotient rule of a limit. So we're requested to find the limit of this particular function f of x as x approaches -1. So for us to do this one, we can be able to use a various range of methods, but we have discussed about the concept of substitution, a method whereby we say that if we have to find the limit of a function, then it's equivalent to the value of a function at that specific number. So in our case, our number that we have been given in this case is -1, and therefore we're going to do a substitution and find this specific limit, implying that we're going to have -1 to power 3 plus 4 into -1 to power 2 minus 3, and this is all over -1 square plus 5, and this is going to give us a value of 0 over 6, which is basically equivalent to 0. Of course, this is one of the applications of the quotient rule, which we had said that the limit of a quotient over two functions is the quotient of their limit, provided that their denominator is not equivalent to 0. And we had given a general representation for this specific case for such a kind of a limit, whereby we said that the limit of a function fx over gx as x approaches a particular value, say, that one can be given in terms of the limit over fx as x approaches c all over the limit over g of x as x approaches c, given as that. And this is going to be in terms of so suppose we had given the initial for limit as L. So suppose the limit for fx is going to be given as L, and for g of x is going to be given as m. Therefore, the limit of this specific function, which is a quotient, is going to be given as L over m, whereby m is not equivalent to 0, as we say. So as we solve this specific case, of course, we are going to see that that particular rule is going to be applicable. And of course, we're going to treat various other aspects of those functions using the same approach. So there are some cases which we are going to see that are going to be unique in a way, but of course that is going to use a different approach apart from substitution, of course, which entail the concept of a conjugate method or factoring, which we are going to use to make our use of using specific example. So basically this is under the concept of a substitution. And then on our next discussion, we're going to look at the concept of finding these limits using the method of a conjugate method or factoring in that specific regard. So that is it for now, guys. Bye, God bless you.